of a proof, if you remember yesterday, is to use deductive reasoning and syllogism to lay out step by step a proof that connects my original hypothesis to my desired final conclusion. Okay? So what I'd like to do today is, before we start actually writing our own proofs, is I'm going to give you some proofs in syllogism form, and you guys are going to write the proofs from them. Okay? So if you look at the first one, actually this little statement didn't get copied. Hold on. Okay. So if you look at the first statement, what's the first thing you have to do in a syllogism? Make sure what? That it's in order. The first thing you have to do is make sure the syllogism is in order. And you can tell it's in order by matching the conclusion of the statement before to the hypothesis of the next statement. Okay? So go through and put this in order. Like which one comes first, second, and third. Okay? So read the statements, the three statements, and tell me which one comes first, which one comes second, which one comes third. Okay? Anybody got that? Who's got that? What'd you get? Okay. Okay. And that's only first. Okay. And the way you would check that is to read it. So if 2x minus 3 minus 7 equals 3, then 2 times x minus 3 equals 10. That conclusion should be the hypothesis in my next statement. And she said the next one is if 2x minus 3 equals 10. So it does. It matches. So we're good. Okay, so if 2 times x minus 3 equals 10, then x minus 3 equals 5. That conclusion should match the next hypothesis, if x minus 3 equals 5. And it does. Okay? So if these are in order, 1, 2, 3, what conclusion could I draw from that syllogism? Ella?
So it would be 2x minus 3 minus 7 3.
Then? Good. Good. It's the final conclusion can be the first hypothesis and the last conclusion. Okay? And in proof language, this becomes our given, and this is our proof. Okay? So given this, we're trying to prove, given this, we're trying to prove that. Okay? And the nice thing about a syllogism is once you get it written, you can just put it in order. You can just use the order and write your statement, your proof in order. Okay? You always start with the first hypothesis, okay, the given. So we're going to start with 2 times x minus 3 minus 7 equals 3. Okay? And then you write all your conclusions in order after that. So if this is true, then what? 2 times x minus 3 equals 10, right? That's my first conclusion. That's a conclusion from statement 1. Okay? And if 2 times x minus 3 equals 10, then what's my next conclusion? Exactly, x minus 3 equals 5. And if x minus 3 equals 5, what's my final conclusion? Great. Okay, and I'm using an algebraic proof. I know it'd probably be easier just to solve the equation, but I want to use an algebraic proof to kind of show you the method that we're going to use, because the next one's going to be geometric. Okay, so I know you're probably thinking, I could have just solved this, and you're right, but I I kind of want to show you the process. Okay, so what's the first one? What's the reason we get to use the first one? It's the given. Okay? Okay, now how did I get from here to here? I added 7. Okay, what property says I can add to both the same thing to both sides? Addition problem. Good. Okay, now how do I get from here to here? Division. Good. We're dividing this side by 2 and this side by 2. When I divide by 2, those cancel and just leaves x minus 3. 10 divided by 2 is 5. So that's the division pound. Okay. And finally, how do I get from here to here? Add 3. So that's my addition pound. Okay? So the steps are, put your syllogism in order. Write your steps of the proof by starting with the first hypothesis and then writing each conclusion from step 1, from step 2, from step 3, and the last conclusion should be your proof statement. Okay? And then you go in and write your reason. Okay? For this one, go ahead and do those 2 steps, and then don't do the reasons yet. We'll do those together. But put these in order, write them into the blanks, and then we'll go and put the reasons together. Okay? So that would be the conclusion I can draw, because it's the first hypothesis, the last conclusion. So this is going to be my given. This will be my given. And this would be my proof. Okay? Now, in a regular proof, you're going to be given that. Instead of being given the syllogism, you're given the beginning and the end, and you have to figure out the syllogisms that come in between. All right? So if I'm going to write it in here, the first thing I write is my original hypothesis, my given. So that would be angle 1 and angle 2 are a linear pair, and angle 3 and angle 4 are a linear pair. And why? Well, we'll do the reasons later. Okay? So if they're a linear pair, then what? They're supplementary. Good. Okay? And if they're supplementary, then what? Right. Does everybody see how we're getting those? We're following along, right? If they are supplementary, then this. Okay? So the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 3 plus the measure of angle 4 equals 180. Okay? And then if that's true, then what? Right, then it's the proof statement. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360. Okay, so that is my logic chain, no breaks, everything follows logically. Now all I have to do is give the reason. Okay, what's the reason for the first one? Given. Yeah. Okay, now if I know, everybody remembers what linear pairs look like, right? They're 2 angles whose outside lines make a line, so they're supplementary. So if I know that angle 1 and angle 2 are a linear pair, why can I say they're supplementary? Yeah, it's the definition. It's the definition of a linear pair. It's 2 adjacent angles that are supplementary. why it was so important when you were doing your flashcards to make sure you had linear pair on there, because we're going to use that in proofs. Okay? And if I know they're a linear pair, why can I say that if I add them up, I get 180? No? How is that true? If they're supplementary, then they can be added together to get 180? Yeah, it's not that. That's the definition of not a linear pair of supplementary angles. Right. Okay? Now, this one's a little bit trickier, but fortunately, we've got them now to measures. So because it's kind of math now, I can go back and think of my pose and my pop. What helps me say that if 1 plus 2 equals 180, then 1 plus 2 plus 3 plus 4 equals 360? What did I just do to go from here to here? Yeah. Remember, the addition pose says if I add the same thing to both sides. Well, the fact that these two are equal tells me they're the same thing. So I'm adding this to this side, and I'm adding the 180 to this side. So that gives me 1, 2, 3, and 4 equals 360. That's the addition pose. Okay? Make sense? Okay. Why don't you guys try the next one? All right, so what's the order, first of all? Sabrina, can you tell me the order? Right? Okay. Right. And you can tell because this conclusion becomes this hypothesis. This conclusion becomes this hypothesis. Okay? So what's my first statement? Ella? Right. B is between A and D, and C is between A and D. What's my next statement? Okay. Your next statement would be, I'm just going to go ahead and talk through this on the recording, and then you guys can listen to it later if you want. So the next one would be if AB plus, yes, sorry. Okay. So the next statement would be if AB plus BD equals AD, and AC plus CD equals AD. Okay? And then your next statement, if that's true, then AD equals AC plus CD. And then your last statement would be then AB plus BD equals AC plus CD. And the reasons would be, obviously the first one's given. The second one, the reason we can say if B is between A and D, AB plus BD equals AD, that's the segment addition postulate. Okay, and then this one here just flips this in a different order, so that would be symmetric pole. And finally, I can take out the AD from here and here and replace that with that because we said they're equal. So that is the substitution.